In this clip, we create the gateway ID and define a new concept for a shared design of the corridors. Now that I have the gateway floors, I can get the gateway ID the same way I got the corridor ID. So I copy the divide and the create corridor ID and connect it to the mark segments subnetwork. By doing that, the gateway floor pieces get combined to one big primitive. The only thing I need to change is of course the name of the attribute. This is no longer the corridor ID, but the gateway ID. I already created a new visualizer for that ID. You can see the gateway ID displayed in the viewport. So at the moment, we have the corridor pieces with their corridor ID, we have the gateway pieces without an ID, and we have the floors with the ID. At the end, we want to merge the corridors and the gateways, but before we can do that, we have to transfer the gateway ID to the gateway walls. And this time, we can indeed use the attribute transfer node. The gateway ID was transferred like it should, but as you can see at these black areas on the gateway, we also transferred the normals of the floors. Whenever you use a transfer node, make sure that this transfer node only transfers what you want to bring over to the other side. So I want to transfer the gateway ID from the primitives, and I definitely don't want to transfer any point attributes. So I deselect that. Then create a merge node and connect both the getCorridorID and the attribute transfer node. It's not that easy to see in the viewport which number displays which attribute, so let's change the color of the gateway ID to something different. A light red should be fine. As you can see, all the gateways have a 0 for the corridor ID and its own gateway ID, as the corridors have it the other way around. We're near the end of this subnetwork, so it makes sense to place an attribute delete node. At the moment we have an attribute tile, which we used at the beginning, but now we don't need it anymore, so let's get rid of it. We could in fact also get rid of the color, but as I mentioned briefly, we can make use of it later and we still can use the visual cue. So now we are at the end of this subnetwork, so I place down a null and this outputs the walls with the IDs. Now this is the approach I took with my first prototype. The idea behind it was to get as much variety as possible, while keeping the overall concept as simple as possible. By having different IDs on each side of the corridor, I can create different designs for each one of them, like windows on the one side and pipes on the other. But I found that sometimes the corridors look much better if the design on both sides are the same. Saying that, I should show you a way to create that option and how you can turn it on or off. For that option, I want to create a control node. So create a null and call it control. I also like to give that node a different color. Then go ahead and edit the parameter interface. Here change the two standard parameters to invisible and then drag in a toggle. This toggle will allow us to switch between different IDs in one corridor or one shared ID. So the name shared seems appropriate. And since we're going to use it, we can already copy that parameter. Back in the mark areas subnetwork, we need to find the right place where we can add the new functionality. Right here after the corridor ID wrangle, we can create a switch that allows to react to the state of the toggle. If it's active, the wrangle gets executed. If not, the path goes through the null, which does nothing. To make the switch react to the toggle, we only need to paste the relative reference into the select input of the switch node. At the moment, the option shared is deactivated. You can see that in the node editor because the second option is visualized as a dotted line. Either way, at the moment we can simply connect the switch node into the second input of the getCorridorID node. We haven't changed anything yet. If the option would be active, the wrangle needs a few more nodes as preparation. So let's pull them down a bit and give this wrangle a proper name. This node is supposed to grab the other side. What does that mean? At the moment, each side gets its own ID. What I want is that the first side does an intersect to the opposite side, gets the ID of that side and brings that back to the origin side. To do the intersect, I need one of the straight normals. To make sure that for this operation each normal is straight, I use again a fuse node. The next operation might not be necessary, but if you have dynamic sizes in your setup, this would be useful. I create a primitive node, activate do transformation, and again reduce the size of that primitive. Now that the primitive is only half as big, I can be sure that the intersect would hit the opposite side. So when the smaller primitive becomes my starting point, I also need the target for my intersect. So connect the original primitive into the second input and go into the editor. As usual, we get the points with the function primPoints, so don't forget to switch the wrangle to primitive. And then we create a few vectors that we will need, like position and the intersect variables. Next we get the normal that I was talking about. Here it doesn't matter which point we use, because each of them is pointing in the same direction. So I just take the point with the index 0. Then I also get the position of that point. And since all of them are pointing away from my target, I have to multiply the normal by -1. And as we learned before, we have to push the origin position of the intersect a tiny bit in the target direction, so that it will not intersect with itself. Then create the intersect with the data of the second input, use the created position and let the intersect go for 4 times the normal length. That's enough to cross the corridor. Then if inter does not hold a -1, the intersect connected. If that's the case, we can immediately set the primitive attribute shared corridor ID. The primitive number where we want to set that attribute is saved in the variable inter, because that is what the function intersect returns, the primitive number of the one that it hit. Now I also have to set this corridor ID as shared corridor ID for the current primitive. If I would not do that, the primitive with the corridor ID 6 would have the shared corridor ID 4, but the one with corridor ID 4 would have shared ID 6. By doing it this way, both corridor sides will have the higher ID as shared ID. Again, to make that visible, I copy the visualizer for the corridor ID and rename it to the newly created shared corridor ID. As you can see, we now have 2 numbers, first the normal corridor ID and below that the shared one. For the rest of our network to work as usual, we have to reverse our primitive transformation. So copy the primitive node and reverse the scaling by increasing the scale up to 2. But there's still one thing to do. When I go one step forward to our get corridor ID and now toggle on the shared mode, there's no new shared corridor ID being transferred. First I have to tell this wrangle the information if the toggle is on or not. For example, by creating a new UI element for this wrangle, which then holds the relative reference to the toggle. So this parameter either has the value 0 if it's deactivated or 1 if it's active. That means I can go back into the editor, create an if condition and simply put in shared as condition. If shared is equals 1, the condition is true, and I use these lines of coding where I set the corridor ID and reuse it for the shared corridor ID. And that worked. Now all pieces of the corridor have an individual corridor ID and also the shared corridor ID if I choose to have that activated. To this point, we only dealt with attributes and numbers. With the next module, we start to create some real detail for our corridors. In this module, you saw a few examples on how you can solve a problem either by using SOPs or VEX. Most of the time both ways work, but sometimes it makes sense to write the function you need by yourself. You also saw how you can manage your geometry by utilizing attributes. This allows you to isolate any part of your geometry. I think the usability of the function intersect was quite easy to see in the clips of this module. When you know how and when to use that function, it becomes a valuable tool for your projects.